Hello and welcome back to week number 12 of our Applied Food Science course, and today we're searching into the seedy underbelly of the culinary world. That's right, we're talking about seeds, which arguably are the most essential food for the evolution of the human race. The idea that our ancestors long ago, one of the things that got them started on the whole farming and agriculture path, rather than being this hunter-gatherer society, was the fact that they found seeds. And they found that not only were these delicious and packed with lots of nutrition and great stuff for them, energy and such, but they could also take them and plant them in the ground, and next year they would have even more seeds to eat. So seeds are critical to the development of the entire human race. So obviously we've got a lot to talk about. Let's get going. Before we get too far into things, I want to talk about the three different types of seeds that are really the big hitters in the culinary world. Okay, to start off, we have our grains or cereals. And the main one you may think of with this is this guy, flour. So flour comes from milled wheat, which basically you just take wheat, grind it up, right, and we get flour. But the other really common one you get is rice. These are also grains or cereals, as you would call them, right? These little kernels. So what makes a grain or cereal? And why do I keep saying grain or cereal? Well, so the idea is the plants that these things come from are referred to as cereals. Okay, wheat is a cereal. That's the type of plant that it is, and it produces grains. Now, usually we use them kind of interchangeably, but that's actually why, like, the breakfast cereal that you eat in the morning is called cereal, because it's made of grains. Okay. But beyond that, the big idea with grains is that they originated in dry climates, usually kind of grew on these plains, which allowed our ancestors to kind of venture out from these forested areas and actually have substantial food there. They usually grow in really tight, densely packed stands, is what they're called, of a bunch of wheat stalks or rice all together. And at the end, they have clusters of their seeds. If you've ever seen, the classic wheat that has a bunch of little seeds at the end, that's what we're talking about. Okay, now our seed type number 2 is the legumes. Now, legumes are most famous for being beans. Pretty much any bean that you see, peas also, lima beans, pinto beans, black beans, whatever they happen to be, even peanuts are legumes. Okay, what makes a legume a legume? Okay, these seeds differ from our grains because they have a protective outer pod that encapsulates the seeds within. Okay, so best to think of, for example, green beans have that kind of outer, thicker, more fibrous pod, and then inside there's really tender beans. Same with peanuts, right? One really important thing about legumes that's really been critical to agriculture for thousands of years is that they are actually the only plant that can affix nitrogen in the soil. That's really important because plants use a lot of nitrogen. They pull nitrogen out of the soil like crazy, especially other grains that people grow, like wheat and corn. But they don't put any nitrogen back, really. It takes a long time for that to go. And so for, hundreds, thousands of years since agriculture has really been a mainstay, primarily of the North or of the Americas, is Native Americans used to grow their corn, and what they would do is they would plant legumes around it, because the corn would take the nitrogen out of the soil, the legumes would put it back in there. That's just an extra little tidbit, though, as to why legumes are important, as well as being delicious. So the final type of seed is probably the one that you are most likely to eat raw, and that is the nuts. So I have here my absolute favorite eating nut, the almond. I love almonds. They're fantastic. Not only are they incredibly good for you, they're great, hugely energy dense, but they're also just delicious, even raw. So, what's going on with nuts? Well, nuts are a little different from grains or legumes in that grains are primarily all grasses, and legumes are all beans. Nuts come from tons of different backgrounds, different plant families. The thing that really keeps them together is that they've got a really big seed. Okay, you think of wheat with our flour, and the seeds are really, really small. Same with a lot of the legumes. Again, if you think of the green bean, right, once you get through that outer pod, the seeds are actually really small, whereas with nuts, the seeds are actually usually really big. And they're also protected by a hard outer shell. Sometimes it'll encompass and enclose the whole nut, like with walnuts or pecans. Sometimes it only covers part of it, like with acorns, for example. Okay, but what the big difference between nuts and other seeds that make them really easy to eat is they store their energy in oils rather than starch. And we'll come back to that later, but keep that in the back of your mind, because it's the fact that we, as humans, we really like to eat and taste oils much more than we like starch, right? If you think about it, you cook with vegetable oil or olive oil. You don't really cook with cornstarch as your base, right? So moving on, we've talked about our three big types, and we'll be coming back to them again and again, but let's take a step back for a second. Let's talk about what a seed really is. Now, seeds, a great way to think of that about them is actually very similarly to one of the first things we talked about, and that's this guy. You remember this guy? Our egg. Because seeds are actually a lot like this egg, right? When we crack the egg open, we see that inside, right, we've got this thick white here, we've got a thin white, and then in the middle, we've got our germ cell. That's what's going to eventually grow into the chick, and it's got this yolk. Now, what do all these things do, right? Well, we have the yolk. That's what provides the nourishment for the germ cell, and seeds also need that. We'll get to that in a second. But the one thing that's really different between eggs and seeds is that the eggs have this white around them. And the main purpose of the white, remember, is just kind of a protective layer, kind of cushions things as this gets jostled around all over the place. Now, and the final thing, of course, lest we forget, is the shell that goes all the way around, the hard outer coating that keeps this thing safe. Now, when we think about nuts, they need the same thing. Remember, a nut or a seed is just a baby plant, and the seed is essentially its transport mechanism into the world. Right? So this thing has to have similar features to the egg. It has to be able to survive away from the parent plant for long enough for it to grow and develop. So let's take a look inside of our seed here and see what's going on. If we crack this open. All right. So what do we got here? It actually should look pretty familiar, right? The first thing you should notice is that on the outside, we have this seed coat or bran. Now, sometimes that takes the form of a hard outer shell, like in pecans or walnuts. Sometimes it's just the it can be the pod for legumes. Sometimes it can be for wheat or grains. Sorry, we call it the bran, right? Which doesn't have to be removed before cooking. But if you've ever had, say, whole wheat bread versus white bread, that's the big difference. Is that in whole wheat bread, the grains keep the bran on the outside, which is actually full of lots of vitamins and minerals, and we'll get to that. But all seeds have this thick outer seed coat, or bran as it's called in grains. Now, in the middle here, we have the cotyledon. Okay, the cotyledon essentially refers to everything that's not the seed coat. This is where the energy and nutrients come from that fuel our baby plant when it needs to grow. And speaking of, at the top here, we have our embryo plant. Okay, so this is just our little baby plant. And you see most times, and you can see this especially in peanuts, are like one of the best ones to look at this. If you ever get a peanut and you kind of crack it in half, in the middle there, sometimes you'll see this little baby plant. And it's not green. It'll usually be the same color as the cotyledon. But that is essentially just a plant waiting to happen. It'll probably have a couple kind of pre-leaves that are just ready to go. Okay, but seeds, right, are very simple. You'll notice the one thing that's missing, right, is the white. I mentioned that earlier. The reason that's missing is that these things aren't nearly as fragile as an egg. Okay, they're not gonna, even if you jostle them up, because the embryo is going to be totally stationary until it gets planted. Essentially, you can build this fortress around it, and you don't need to worry about it having wiggle room to grow in the seed, because once it's planted, then the seed will sprout. It'll do its own thing. So there is our seed. Okay, so just a reminder, seed coat bran is protective. Cotyledon provides the energy for that initial plant growth. And then we have the embryo, which is going to become our baby plant. So let's talk about, I mentioned that seeds are kind of that staple food that let us humans evolve to where we are now. But why is that? Well, it comes back to what seeds are meant for in the first place. You see, seeds, like we said, are supposed to be these kind of carrying cases for baby plants. They need to have everything in them for a new baby plant to survive and grow, even without any of that extra stuff there immediately. So that means that seeds need to have a lot of really good stuff inside them, enough, the complete package, so to speak, to allow for this baby plant to grow. So that means it's going to have tons of carbohydrates, protein, fat, vitamins, minerals, fiber, everything that you need as a new baby plant. And incidentally, as a new baby human, or adult human, or teenage human, though it has everything that we could possibly want. Okay? But just to point out a few things that are really important. Seeds, nuts especially, are really high in carbohydrates. Now carbohydrates, going back again, carbohydrates are really good because they offer us energy. Carbohydrates, sugars, those are the same exact thing. Okay? And so that's why bread, right, made out of flour, is basically all carbs, because flour is mostly energy, carbohydrates, okay? The other thing that these seeds have a lot of is protein, and that protein is phenomenal for us. We need, there's 20 essential amino acids, right, that humans need to live and grow. Now, we can make some of those, but there are 11 that we cannot produce ourselves. We have to consume them from somewhere else. It's 11 or 9, I can't remember. I'll post it in the comments. Important thing is that these seeds are a great place to get those. In fact, for years, beans and rice has been a staple of cultures all over the planet. Why is that? Well, as it turns out, if you combine beans and rice, you now have what we call in the nutrition industry a complete protein. That is to say that you will get all of your essential amino acids from just these two foods. So theoretically, you could subsist on nothing but grains and protein, at least grains and beans, at least in a protein sense of things. But that's not all they provide. They're also great sources of things like vitamin B, which is really excellent for your immune system, your development. And there have actually been cases of these diseases resulting from a deficiency in some really key vitamins that we need from grains because of the different ways they're processed. Okay, and this brings up the next big point I want to talk about is that while there is tons of good stuff packed away inside of any seed, not all of it is accessible unless you do it the right way. Okay, and that's going to be one of the big themes I want you guys to come out of this lesson with, is that while there's tons of good stuff packed away inside of any seed, accessing it is the real challenge. So I would like to present to you two cases. The first you might have heard of is beriberi. Now what is beriberi? Well, it turns out that beriberi is a disease that results from a deficiency in thiamine, which is a molecule that's found in rice. It's specifically found in the coating of rice. A while ago, I'm not going to give you a year because I'm not totally sure, but rice is a staple food, especially in Southeast Asia. And for the longest time, they just cook the whole rice grain. And as it turns out, in the coating, in the bran around the rice, there's a lot of thiamine in there, which is key to not getting beriberi. Now, they went through, eventually Westerners came over and they kind of showed them new techniques for handling grains, and one of them involved removing the seed coat, or the bran. And after they started doing this, which makes it a lot easier to digest, it tastes a little better because there's some kind of bitter compounds in that bran. People started eating basically exclusively rice that had the bran removed. But little did they know that the bran was actually housing a key nutrient, thiamine. And without it, they all started getting beriberi. A very similar thing happened to people that came over to North America and started eating a diet really high in corn. Because as it turns out, corn, you have to cook it a certain way to get access to its niacin. And you have to kind of cook it in this alkali solution, which is basic, right opposite of acid. You don't need to worry about that. The important thing is that without cooking this correctly, they didn't have access to the niacin that was locked away inside this corn. And because of that, a lot of people got pellagra. So if you've ever heard of pellagra, that's due to a niacin deficiency, which comes from if you're mainly eating corn as your grain source, your seed source, you need to get access to that niacin. Okay. Now, fear not. Most of these vitamins are actually everywhere in our diet nowadays. We eat a very much more varied diet than a lot of people over the past, 500-600 years, 1,000 years. And so we usually don't have to worry about these things. But just to make sure, you might have noticed that breakfast cereals are often fortified with a lot of these extra vitamins and minerals, B vitamins, thiamine, niacin. Because the way that they process the grains that go into those, they remove a lot of that, they remove the bran almost entirely from any of the flour that they use, and so they lose a lot of those vitamins. Okay, so I keep talking about these vitamins. What are they good for? Well, as it turns out, eating whole grains, again, the point is these vitamins and minerals are everywhere in this thing. But you have to eat the whole thing. Eating whole grains has been associated with things ranging from a decreased rate of cancer, a lower chance of heart disease, even a reduced risk of diabetes. So this stuff's great. Now, on the flip side of this, it should be noted that seeds are actually one of the most common allergens on the planet. In fact, about 2% of adults and about 8% of kids are allergic to some kind of nut or grain or legume, which is huge. And reasons for that are kind of speculated about, and so I'm not really going to go in them, but it's a big number. And the problem with this is, unlike, say, foodborne illness, cooking your seeds isn't going to kill the allergen, right? These allergens are usually proteins in there, and you're not going to change the protein. You're still going to eat it. Okay. The other big issue that people face when it comes to seeds, grains specifically, is gluten intolerance, also known as celiac disease, which is a really unfortunate disease where if you ingest gluten, your immune system will attack the cells in your intestines, which are responsible for uptaking those gluten nutrients, and really give you a bad time. Okay, gluten comes from when you take flour or wheat proteins and you agitate them in the presence of water or egg, and that forms gluten. So really, at this point, kind of the only way to avoid that unfortunate circumstance is to avoid gluten altogether, which sounds rough, but isn't as bad as you'd think. There are tons of substitutes. There are lots of different flours. Rice flour is an excellent substitute. Corn, quinoa, there's all sorts of grains you can substitute for flour, but just watch out. Now, I do want to mention, this is something personal to me, there is a difference between gluten intolerance and people that just don't like gluten. I know there's a big craze in America right now saying, oh, we want gluten-free stuff. Listen, gluten is not innately bad for you. A lot of people associate it with that because gluten forms most readily from processed flour, the white stuff, right? All-purpose, okay? That is the most refined and nutrient-less way that you can present flour. So a lot of the bad stuff that goes along with gluten isn't from gluten. It's because people are using all-purpose white, heavily processed flour. If you're really concerned about that, you can do the same thing, just switch to whole wheat flour. Oftentimes it takes a little altering the recipes that you've got, but it can be just as good and absolutely wonderful for you. So now that said, let's move on to, we've talked about what's in there, right? So let's really get into the nitty gritty. All right. First, let's start talking about proteins. Now, the proteins in seeds can kind of be broken down into 4 categories based on what they dissolve in. Okay, so for nuts and legumes, most of the proteins in those are water soluble, which means they dissolve in water, or they dissolve in water and salt. A great example to think of here is if you've ever cooked beans before, inevitably the water is going to end up really having being a little thicker and having the color of the bean itself because those proteins are seeping out into the water. Now, if you take flour and you put it, or wheat and put it in water and boil it, not a lot's going to happen. Okay, for wheat, for grains, you need to extract those proteins with alcohols or in an acidic solution. Now that said, it's not always necessary to dissolve them. It's great for legumes because a lot of people actually really like their beans nice and juicy and to kind of have that thickness to them. With flour, there's actually a benefit to this not dissolving in water because then the proteins will actually clump together and give you that stickiness that is necessary to make a dough. That's good. Okay, now moving on. So we talked about proteins. How about the sugar that's in there? Remember I told you there's tons of energy in these things. What is it? Well, when it comes to nuts, the energy, as we said, is packed away in oils. That's why these things are so good to eat raw, because we like to eat oil. Okay. Now, for legumes and for grains, the energy is packed away in starch. Now, we've talked about starch before, but the quick reminder, starch is just a chain of sugars, and there's really two forms that starch can take when it comes to grains and legumes. It can either be an amylose form, which is a single long chain, which can be somewhere in the neighborhood of 1,000 sugars, or 100 sugars, just lined up end to end. 100, not 1,000, sorry. 100 sugars just lined up end to end, straight line. Or the other choice is amylopectin, which is branched. There's lots of branches that come out from that. You can have hundreds of branches coming out, and usually there's a lot more sugars, 500 to maybe 2,000 sugars. Okay. And they each have their benefits. They each have their downfalls. The thing about having starch in these is most foods most of these seeds with starch are mostly amylose, and they're mostly amylopectin. They're less amylose, so there's very small percentage of amylose, high percentage of amylopectin. Okay, and what that means, so amylose, the thing about it is because it's straight, all of these can line up in a very structured manner, and that makes it a lot harder to access that starch. Okay, similarly, if you do access it by heating it up, which usually if you heat up a starch around 140 to 160 degrees, we get this event called gelatinization. Now, it's a bit misleading because gelatinization would make you think there's gelatin involved, but there's not. It's just starches being released from one another. Now, these long chains of sugar, once they're released, are going to really thicken things up, which is why it's called gelatinization, because it's very similar texture that you get out of there. Now, one of the problems is that as this cools back down, it will undergo a process called retrogradation. So retrogradation is just these starch molecules realigning up with each other. Now, a great example to think of here is staling of bread. So when bread is cooked, it's nice and soft and chewy and wonderful. But if you let a loaf of bread sit out for a day, it's going to undergo retrogradation. Its starches are going to slowly start to realign, and that's what makes it stale. It makes it really stiff because all these things are getting back in order. Okay. The other great thing to think about would be, say, if you've ever gotten Chinese takeout and you come home with that nice box of rice and it's real good and kind of chewy and delicious, and you put it in the fridge overnight, you come back and get it in the morning and it's hard as a rock. That's because long grain rices have a lot more amylose than short grain rices. Okay, so like this, my favorite of all the rices, arborio. This is a short grain rice, which means that it's got a lot more amylopectin than a long grain rice. And so when this cools down, there's not as much of these very straight pieces of starch to realign and really form solid structures. Whereas with your long grain rices, they line up like nice little soldiers and make it really tough. But what can we take away from this? We can say that heating up that rice again should release the starch, and you'll be good to go. Okay, now the final couple things here, flavor-wise. Keep in mind that when we talk about flavor, right, flavor comes from what we smell, the aromas that this thing has. And most of the flavor compounds are in the outside, the seed coat or the bran. That's why all-purpose flour, while it makes bread that we consider really delicious, it doesn't have a lot of flavor. It's usually the texture that we're after. Whole wheat bread has way more flavor, and the reason is because the flavor molecules are in the bran, they're in the seed coat. Okay, more proof, take a nut, take an almond, scrape off the skin on there and taste that. It's going to have a lot more flavor. Maybe not good, but much more flavor than the inside. Okay, now when it comes to cooking these, all right, there's just a couple things to remember. One, when it comes to nuts, as we've said again and again today, you don't need to cook these. Their sugars are in oil form, and we like that, and we're going to enjoy that thoroughly without cooking. But if you want to, toasting nuts, never a bad idea. As for legumes, we need to penetrate these legumes with both water and heat. Heat to gelatinize the starch, and water to spread it all out. Now remember, heat penetrates a lot faster than water, so it's always good when you're cooking with legumes to give them a pre-soak. Let them soak in some water before you hit it with the heat. That way, as soon as you hit it with the heat, that gelatinizing starches will be able to be absorbed into the water, and you're going to get cooking a lot faster. So that about covers it for seeds today. Thanks for watching, and I'll see you in the bonus round. Bye.